Okay, this is chapter 2.3, functions. The vocabulary you need to know here is, one of the words is dependent variable. Okay, your dependent variable is your y. Okay, that's usually called your output. The independent variable is the x variable, and we call that the input. A relation, an equation that produces ordered pairs. Okay, for example, if you put 2x plus 1 equals y, and you made a t-chart, if x equals 1, then 2 times 1 plus 1 equals 3. So you have an ordered pair of 1 and 3. Every time I put in input, I get output, which is called an ordered pair. That's a relation. Okay, a function is when you have a relation, such as 2x plus 1 equals y, and none of the x's repeat. X's cannot repeat. So 1 and 3, if I put in another number 2, 2 times 2 is 4, 4 plus 1 is 5. Anytime I put in a 2 for input, I'm always going to get 5 for my output. And that would be how you could describe a function. Okay, your domain is the set of all x's. So in this little chart I've got going here so far, the domain is 1 and 2. Okay, actually I could put any number in here. Okay, so all real numbers could be put into my domain. Okay, the range is the set of all y values. Okay, your y values are your output, remember. So everything in this column is my range. And again, this particular function is going to produce all real numbers for a range. Okay, function notation, you're replacing y equals with f of x. Okay, an increasing function, all of your output is increasing. In other words, all of your y values are getting larger as you move from left to right. Okay, all output is decreasing with a decreasing function. So all of my y's are decreasing as my x's are getting larger. Okay, the constant function, all output stays the same. In this section of chapter 2, we need to be able to determine if a relation is a function. Okay, by looking at your x's in a set of ordered pairs, if any of the x's repeat, it's not a function. And you can also do the vertical line test if you have a graph. Okay, determine your domain. Okay, the set of all x values that is possible for your input. Again, for example, on 2x plus 1, y equal to x plus 1, looking at this number line that I have here, if I go from negative infinity to positive infinity, every single one of those numbers is possible for my domain. Okay, determine the range. The range is the set of all y values produced as a result. Okay, so on the previous example, your range is going to be all real numbers as well. Okay, determine where a graph is increasing. To determine where the graph is increasing, okay, we're going to start right here at 0. Notice 0 is part of the graph, so I'm going to put a bracket there. And as I move along the x-axis, every value in my graph is getting larger and larger. Okay? And this arrow indicates that it doesn't stop, so that's where the infinity. So it goes from 0 to infinity. Determine where the graph is decreasing. The same process, although on this graph it starts at -1. So I'm going to put a bracket because it does include that. And as I move to the right along the x-axis, every value in the y is getting smaller and smaller. So the graph is decreasing on the interval from -1 to infinity. And determine if a graph is constant. If you look at your graph, let's say we have a line through y equals 3. None of my y values are changing, so that's constant. Okay, let's look at some ordered pairs here. We're going to look at these 3 sets of ordered pairs, and I want to determine if this represents a function or not. On set F, if I look at every x value, it's different, so that is a function. Okay, on set G, notice that the x value of 1 repeats itself, so that is not a function. On set H, -2 for x repeats itself, so that is not a function either. Okay, on this next little set over here on A, it says give the domain and range of each relation. I'm also going to determine if it is a function or not. Okay, first thing I'm going to do is do the vertical line test. Okay, I'm going to draw a vertical line here. And if my points cross this line more than once, it's not a function. So right here, only one point touches the line. Okay, if I move it along, only 1 point, only 1 point, only 1 point. So A is a function. And the domain of this function is all of my x values. And since none of these points are connected, then I'm going to have to list my domain. So the smallest x value is -1. And then 0 is the next one. And then the next one is 1. And the next one is 4. Okay, the range of this function, look at that point there. Okay, the smallest y value I have is -3, and that goes with the 4. Okay, the next smallest number I have is -1, and that goes with 0. Okay, and the next one up is 1, and it goes with -1. And then the next one is 2, and that goes with the 2. So my range is all of these numbers over here. Okay, look at example B. I'm going to do the vertical line test here. Notice that on the circle, it crosses the vertical line twice. Everywhere I move the vertical line, so that is not a function. Okay, the domain, since all points are connected here, then I'm going to write my domain as an interval. Okay, the domain is along the x-axis. The smallest number is -4. The greatest number is +4. So I'm going to write it like this. From -4 to +4, all x values represent the domain. The range is along the y-axis. The smallest y value is -6. The largest is +6. So the range is an interval from -6 to +6. Okay, on example C, if I do the vertical line test, notice that it only crosses my vertical line one time anywhere I put the vertical line. So this is a function. Okay, the domain goes from negative infinity to positive infinity. Negative infinity to positive infinity. Any number for x along that number line there will work in this function. The range is the same from negative infinity all the way to positive infinity. All my results will be on that number line. Okay, on example D, take the vertical line test. Again, we have another function. It never crosses the vertical line more than once. Okay, the domain along the x-axis here, notice I have arrows, so every single number along the x-axis is part of the domain, from negative infinity to positive infinity. Okay, my range, however, is a little different here. On this parabola, it never goes below -3. So the smallest value is -3. Okay, and since it includes that number, I'm going to put a bracket. But it goes up forever. So it goes all the way to positive infinity. Okay, decide whether each relation defines a function and give the domain and range. Okay, we're just going to look at a couple of these. On choice A, here, example A, y equals x plus 4. Okay, this is a function because any value I put in for x is just going to give me a y value that is 4 greater than x. Okay, so all real numbers is going to represent the domain and the range here, and it is a function. Let's look at example B. Y equals the square root of 2x minus 1. Remember, we cannot have a negative number underneath a radical, so 2x minus 1 less than 0. I need to find out when that's going to be less than 0. So 2x less than 1, x less than 1/2. Okay, if x is ever less than 1/2, then I'm going to get a negative number. Okay, so for example, 2 times 1/2 minus 1 equals 1 minus 1, which is 0. That one is okay to use. Okay, the square root of 0 equals 0, so that's good. So if my input is 1/2, my output is 0, and that's good. But if I take a number that is less than 1/2, 1/4, for example, okay, 2 times 1/4 is 1/2. 1/2 minus 1 is negative 1/2. The square root of a negative number cannot be graphed, therefore that is not going to be in the domain. So 1/4 gives me negative square root of negative 1/2. That is not going to work out in the domain. Okay, so to write the domain here, we would put that that x has to be greater than, greater than 1/2 or equal to 1/2. So the domain is equal to 1/2 comma positive infinity. And then the range of this function, since it's 0 is the very first number that is allowed as my output, okay, it's going to be 0 to infinity. It's never going to fall below 0.